Welcome to Unit 2, Lesson 7. Today we're going to be estimating and solving decimal addition problems mentally. I'm going to show you how to group them so that you can solve them in your head. Here's a math problem that you might find overwhelming to do in your head. However, this problem really is quite simple to do in your head if you're willing to take a look at these numbers and try to find ways to group them. For example, what I see right off the bat is that I have 50,000 and 50,000, and I can group these two to make 100,000. So in my mind, on one side of my whiteboard in my head, because in my head I can imagine anything, so I imagine there being a whiteboard, and on the left side I'm putting 100,000 as one grouping. If I keep looking for ways to group numbers to add them easily in my head, I see another group here, 25,000 and 75,000. And if you group those, you're also looking at 100,000. So again, in my mind, on the left-hand side where I already have 100,000, I'm adding to that another 100,000, which is easy enough to add in your head. That makes 200,000. And then I only have one number left. That's 38,000. So I'll just add that to what I already have, 200,000. And that leaves me with 238,000 as my final answer. Now what I did in order to add these mentally was I regrouped them. I rearranged the order in which I added them. And you're allowed to do that when adding. And there's a property, a rule, or a characterization that we use when adding. There's a name for this property. Commutative. The commutative property of addition says it doesn't matter what order in which you add them, the sum will still remain the same. You know this property. You know that 3 plus 1 is equal to 1 plus 3. So we're allowed to rearrange these numbers any way we want in order to make this problem easier to solve. That's what you should be doing today, using the commutative property to rearrange your numbers in a pattern that's easy for you to add in your head. Here's another problem that we can practice with using decimals. See if you can get a head start on me here. See if you can figure out which two numbers you want to add together first. Look for numbers you can group easily together. All right, the first two numbers I see that are easiest to add in my mind are 0.5 and 0.5, or 1/2 plus 1/2, which equals 1 whole. So in my whiteboard in my head, on the left-hand side, I'm putting that one aside, and I've already added those two together. So I don't need to worry about these anymore. And then I'm going to look for the next easiest grouping, which is my 75 cents plus my 25 cents. And even though this isn't money, I can easily equate it to money. And 75 cents plus 25 cents is $1, so I'm going to add that one now to the one I already had, which in my mind now I have 2 whole. I've added those two in my head. And now it leaves me with 38 hundredths, so I simply can just add that to what I already have, which is 2. So it leaves me as 2 and 38 hundredths. This should have been your final answer, and it should be one that you could get in your head because you're using what property? What is the name of that property again that allows us to rearrange the order in which we add? That's right, the commutative property. That's the property we're using today. Let's try this again, but yet with fractions. We've used whole numbers, we've used decimals. It's time to use fractions to see if we can add them together in our head. And we're still looking for two fractions that we could easily add in our head. Which two fractions will you pick first? Well, I see a 3/4 and a 1/4. And I know that since they have the same denominator, that makes them easy to add in my head. I also know that 3 plus 1 is 4, and 4/4 equals 1. So when I add these two together, I get 1 whole. So what is next? Well, I also see two other fractions that again have the same denominator. These are going to be easy ways for me to figure out what to add first because like denominators are easier to add than unlike denominators. And when I add 2 and 4/5 with 1/5, well, the 2 I can just kind of leave outside of the problem for now and just add 4/5 plus 1/5, which is 5/5, which is a whole. If I take that whole and add it to the 2 I started with, I would end up with 3 wholes. So 2 and 4/5 plus 1/5 equals 3 wholes. So in my mind I have 3 wholes plus I have the original 1 whole. When I add those together I have 4 wholes. Now I'm going to add the 4 with what I have remaining, which is 5/17. And that's just as simple as saying 4 and 5/17. That's all I needed to do there. And so my final answer is 4 and 5/17. I was able to do that in my head because I didn't have to go in the same order that it was written in. And the reason I didn't have to go in the same order is because of a particular property that we've been learning about, and the name of that property is commutative. So you learned how to group numbers together to make them easier to add in your head, and you learned why you're able to do that, because of the commutative property. There's another property we need to talk about. In the box in the middle of this page, you see 2 properties: the commutative property, which we've already talked about plenty in this video, and then the associative property, which we have not talked about yet, but you're probably familiar with. If you take a look at what the associative property means, this equation is what it means. A plus B in parentheses, meaning you have to solve that first, plus C is the same as A plus B plus C in parentheses, meaning you have to solve this first. The parentheses are just a set of directions telling you to do this first. Well, the commutative property says that you can do anything you want first. You don't need a set of directions. You don't need parentheses to add B to C or A to B here. You can do anything you want because commutative property says it doesn't matter. Associative property uses parentheses to give you specific directions on what to add first. But because we're just adding, and that's all we're doing here, it doesn't matter, as we know from the commutative property, what we add first. Parentheses are not even really necessary. So in a sense, if you go to number 1, you could use the commutative property to add any numbers in any order that you want to. Or you could use the associative property and put parentheses around 2 of these numbers to tell somebody to add those 2 first. So either property could be mentioned when solving an addition problem mentally, because you get to choose which 2 numbers you want to add together first, and you could either put parentheses around them and call that the associative property, or you don't have to use parentheses and just say I'm using the commutative property and adding them in any order that I want to. Now I would like you to solve questions 1 through 7 on page 51 of your workbook. You can use and should use mental math and the 2 properties we've learned about already to solve these problems. You shouldn't be adding the traditional way. You need to use mental math. You're also supposed to show or write how you did it. If you want, you can just use lines to pair up numbers. So if you were going to add these 2 numbers together, you would show it by combining them with a bracket like that. That will show me which pairs of numbers you added or grouped together, and then I will know what was happening in your mind when you added them. So I want to see some work for these, and you can either write out in words which 2 numbers you added together first, or you can show me by combining them with lines. Complete page 51, then come back to the video for the remainder of this lesson. The last thing we need to talk about today is the distributive property. The distributive property is the most complex property we have for addition and multiplication. I'm first going to show you exactly what the distributive property is and what it means and why it works. And then I'm going to show you how you can use them to solve some problems mentally. Let's take a look at the distributive property. The distributive property says that when you take a number like A and multiply it by a number grouped in parentheses, two numbers grouped in parentheses, B or C, that you're then allowed to take A and multiply it to B, and then add A multiplied to C, and you'll get the same answer. Now that is complicated when you hear it said that way. But if we take our letters and turn them into real numbers, and A equals 2, B equals 3, and C equals 4, we can see how this really does work. So we take our A, which is 2 times our B and our C, which is 3 plus 4. 2 times 3 plus 4. If we solve this as is, the way I would ask you to solve it is to box the first thing you're going to do. This is how we solve multiple operation problems. We box the first thing we're going to do. Then we solve it to get 7. And we rewrite everything else. We end up with 2 times 7. Then we box that and we solve it. We get 14. And when we do multiple operation problems, we always do it this way, one step at a time, because there are rules to the order in which you should do things. And the first rule is always do parentheses first. Now this side of the equation is 14. And if the distributive property works properly, we've rewritten it to the right-hand side. We'll solve that and we should get the same thing. So what we're saying is 2 times 3 plus 4, if you add 3 plus 4 first, is the same thing as taking your 2 and multiplying it by 3, then multiplying 2 times 4. So multiplying your 2 times your 3, and then your 2 times your 4, and then adding those two answers together. So let's see if that works. We're going to box, and if you have 2 parentheses in your first step, I allow you to box them both and get both of them out of the way, and then solve 6 and 8, rewrite everything else. The plus sign is the only thing left to rewrite. Box and solve again and get 14. So you can see that this works. We get the same answer, so both sides are in fact equal. So now let's move on to how we could use this to solve problems mentally. All right, we're going to take a look at the problem we just did. I just transferred it over to a new page so that you can see again how the distributive property really works. Here we're taking 2, multiplying it to the sum of 3 plus 4. And the distributive property says we can rewrite this to 2 times 3 plus 2 times 4. And what we're going to be doing to solve mentally is actually working backwards. We're going to start with this side of the equation. So I'm going to give you a problem that looks like this, and you're going to distribute it backwards so that it will look like this and be easier to solve. So here's our new problem that we're going to distribute and solve mentally. So here we have 3 times 10 plus 3 times 20. You could probably mentally solve each of these within their parentheses in your head, and then maybe possibly add those in your head. You might be able to do it that way. But you can also use the distributive property to take out the common number that you're multiplying in these parentheses, which is 3. Pull that out, and then multiply that to 10 plus 20. We're going to add the other two factors. If we do that, then we could quickly add 10 plus 20 in our heads, which is 30. And in our mind, we're multiplying 3 times 30 to get 90. So there's one way to do it. I also believe you probably could have multiplied these two in your head and got 30, put that number aside, and then multiplied these two numbers quickly in your head to get 60, put those numbers aside, and then add them to get 90 that way as well. I don't think there's a problem with doing it either way, and whichever way is most useful to you, you should use. The distributive property can be a complicated, hard property to remember, and so I'm not saying that one way is better than the other, but you can certainly use any way that works for you to solve them mentally. You may go on now and complete workbook page number 52. You'll be using the 3 properties you just learned about to help you solve problems mentally.